Good morning students, welcome to basic electrical lectures. So we are doing module 4 lecture series, that is topic is DC generators. So we covered all the theoretical topics and we are doing problems on generators. So generally they will ask two types of problems on generators. One is problems on EMF equation that I covered in previous lecture, around 6 to 7 problems I have done it. And then in this lecture I am doing problems on types of DC generators. Okay, so we can start. So class number 7, part 2. Part 1 is problems on EMF equation of generators, and part 2 lectures are problems on types of generators. So just go through the problems whatever I have solved in this videos. So that much problems is more than sufficient to face the university questions. Okay, we can start with university question on type of generator. See, a 30 kilowatt, okay, that is a power, 300 volt DC shunt generator. What type of generator? Shunt generator. As an armature resistance of Ra given 0.05 and the field resistance of 100 ohms. See, field resistance means which field? Shunt field or series field? No, it is shunt field because they given shunt generator. So the corresponding field resistance will be shunt field resistance. Calculate power developed. Say they asked power developed. So we have two types of power developed and power delivered. If they ask power developed means then given power will be delivered power. So calculate the power developed by the armature when it delivers. See, when it delivers means this much power. When it delivers this much power, then how much power is developed in the generator? That is the question they asked. Developed by the armature when it delivers full output power. So the corresponding this power is output power. So let's start the solution for this in detail. So first you write the DC shunt generator diagram. So I am writing that. So please help me how to write the diagram. What do I mean by shunt generator? The shunt field winding connected across armature is called shunt generator. So this is a load point. So LOAD, load. Voltage available at the load point is nothing but terminal voltage, and this is shunt field winding resistance RSH and armature current. Machine will develop current, armature current. So this will be the armature resistance. How much? 0.05 ohms given in the question, armature resistance. So we know that generator will going to induce some voltage, e.g. Now RSH, let assume load is having some resistance RL, load resistance RL. So now these two are connected in parallel. So supply current, this IA current will divide in these two branches. So part of the current flows through shunt field winding is ISH, and part of the current flows through load is load current IL. But the given the output delivered power is 30 kilowatt. So the given power delivered is 30 kilowatt. At what voltage? At 300 volt. So terminal voltage is 300 volt. Okay. So what is the question they asked is power developed. See, for all types of generators, power developed is given by this equation, Eg into Ia. Generated voltage into armature current. If you multiply this two, you will get power developed equation. This equation is same for all types of generators. Okay, either shunt or series or long shunt compound or short shunt compound. For all such generators, this equation remains same. What is our goal? We have to find what is the value of Eg and what is the value of Ia. After finding those values, substitute here, you will get final answer. That is the question they asked in this problem. We can write equation for Ia. So that equation is nothing but current relation. Okay. See, apply KCL at this node, Kirchhoff current law. Entering current is Ia. What are the current outgoing? ISH is outgoing and IL is outgoing. So therefore, we can write, so ISH plus IL. Addition of those two currents will give an armature current. Let you find what is the current of this and this. So how to find ISH current? How to find ISH? What is current formula according to Ohm's law? I is equal to V by R. Which current I am finding? Shunt field current. So what is the voltage across shunt field winding? Terminal voltage. These two are connected in parallel. Whatever the voltage for this resistance, same resistance for this also. The same voltage for this resistance also. So therefore, I am going to write now Vt, terminal voltage divided by shunt field resistance. Vt by RSH will give this voltage by this resistance will give this current. So therefore, what is Vt? 300 volt. What is the shunt field resistance given in the problem? 100 ohm. So at 300 by 100, how much? Okay, very good. We get 3 ampere. Similarly, find the load current. See, to find the load current, again you can take this ratio only. Vt by RL will give IL. But load resistance is not given in the question. So therefore, you don't take with that relation to find IL. Don't take Vt by RL because RL data is unknown. You cannot find IL from using RL. Otherwise, first find RL, then Vt by RL, then it gives IL. That is lengthy process. Instead of doing that, see, across the load, output power is given and output voltage is given. Load voltage, load power is given. Then we can easily find load current. From the power equation, power is equal to Vi. So now, look at here. Power is equal to Vt into IL. Actually, this is also called power delivered equation. So, power delivered. So, I will write here power delivered. Okay. So, from this you find the load current. So, what is the load current? Power delivered divided by terminal voltage. How much power is delivered? 30 kilowatt. Very good. So 30 kilowatt, 30 into 10 power 3 divided by 300 volt. So guys, do this in calculator. You will get 100 amperes, not 300. Okay, you will get 100. So I got load current as 100 ampere. Now add these two currents, IL and ISH. That gives Ia. So therefore, what will be your Ia current? What is shunt field current? 3 ampere. Plus what is the load current? 100 ampere. 100 plus 3, 103 amperes. Don't use calculator for doing all these things. So armature current is 103. So I calculated Ia. Next I need to find Eg. How to find Eg? Eg formula is, you should apply KVL for the outer loop. That is called voltage relation. You must remember all such relations. Voltage relation of DC shunt generator is Eg is equal to Vt plus IaRa. What is terminal voltage? 300 plus what is the armature current? 103. What is the armature resistance? 0.05. So you just multiply, do the simplification in calculator. How much you will get? Tell the answer. Okay, 305. Okay, 15. So very good. So we got answer 305.15 volts. Now we got power developed. Eg value this one, Ia value that one. Okay, 103. So what is Eg? 305.15 into what is the armature current? 103. Guys, now multiply these two readings. That gives your power developed. So what is the answer? 31,430.45 watts. This much watt is power developed. But we can keep the answer in kilowatt because it is more than 1000. Represent your solution in kilowatts. So then it becomes 31.43045 kilowatt kW. So guys, this completes the solution. What is this? Power developed. See, this much power is developed in the machine. What is the power delivered to the load point? 30 kilowatt. What about remaining power? That power is wasted in the form of losses. Okay, that is armature copper loss and shunt field copper loss. Due to that copper losses, your output power is not at all equal to input power. So along with this, if they ask additional extra question, determine efficiency means, so what is efficiency? Output power divided by input power. 30 kilowatt divided by 31.43 kilowatt into 100. That gives efficiency of the given shunt generator. Okay, got it? Okay guys, I hope you understood this. So please pause the video and then copy down whatever I explained. Okay, neatly copy down. Okay, dear students, we can solve the second question asked in university examination on type of generator. So this question asked for 8 marks in for 18 scheme syllabus. What type of generator? Shunt generator. A shunt generator running at 500 RPM delivers 50 kilowatt. Delivers means output power. Developed means input power. It delivers 50 kilowatt at this voltage. What is this voltage then? Output side in generator output voltage is what? Terminal voltage. Vt is 200. The armature and field resistance are, armature resistance is 0.02 and field resistance are 40 ohms respectively. Calculate generated EMF if the brush drop is 1 volt per brush. Okay, so this is again problem on shunt generator. So we can solve this. See, first guys, while solving, you just write the diagram of the given type of generator so that you can easily analyze. You can't do any mistakes further. Okay, so just draw a diagram neatly. See what I am writing this now. This part is called brushes. These two are brushes. Minimum possible brushes is 2, irrespective of any type of winding they have mentioned, lap or wave winding. If wave winding means you take 2 brushes only. In lap winding, you can take brushes as minimum 2, maximum number of brushes is equal to number of poles in lap winding. Okay. So now, DC shunt generator. So the shunt field winding is connected across the armature is called shunt generator. So how much you practice, once you understand, next step is you should practice more and more. So till that is fixed in your mind. So what is the Vt given? 200 volts. The terminal voltage is 200 and at a output power, delivered power is 50 kilowatt, 50. So the current flowing through the load is IL. Load is having some resistance RL. Shunt field winding some resistance RSH, and that is given in the problem. What is the shunt field resistance given? 40 ohms. And what is the armature resistance given? 0.02 ohms. The armature developed current Ia, that current will going to deliver to the load points. So in the load side, these two are in parallel, the supply current divide in these two branches. So this current is ISH. Current flowing to the shunt field winding is ISH. What is the question they asked is, calculate the generated EMF. You have to find EG. Calculate generated EMF. They given, if the brush drop is 1 volt per brush. If the brush drop is 1 volt per brush. See, later we can find this. However, now write voltage relation for DC shunt generator. So, voltage relation for generator is Vt plus IaRa plus, see, in this problem, they given brush drop data. Whenever they given brush drop data, you have to add here V brush drop, means total brush drop. V brush drop. Whenever they given brush drop data, in the same voltage equation, you had V brush drop. So now Vt is given how much? 200. Next I need to find armature current. So how to find armature current? Same procedure. What you done in the previous problem of this lecture, follow the same method. So Ia is equal to, apply KCL at this node. Entering is Ia, outgoing currents are IL and ISH. Add the outgoing currents, IL plus ISH. Now find IL. See, to find IL, power and voltage given. From that data you find IL. Okay, IL is equal to P by Vt. This power is delivered power. What is the delivered power given? 50 kilowatt. Divided by, what is the voltage? 200. So do this, you will get 250 ampere. So I will do that. I have little doubt of that value. That we can do it. Okay, so it is 250. and now shunt field current ISH is equal to Vt by RSH. Vt by RSH. Vt divided by the shunt field resistance. This voltage by this resistance, we can find the current. So what is Vt? 200. And what is RSH? 40. So 200 by 40, how much you will get? 5 ampere or 4 ampere? Very good. 5 ampere. So 200 by 40. So we got 5 ampere. So now add these two currents. That gives armature current. Armature current is equal to load current is 250 plus your shunt field current is 5. So final answer is 205 ampere. So Vt is 200. So now we can find Eg directly. Vt is how much? 200. See how I written this equation is, you should apply KVL to the outer loop. That I explained in voltage and current relations on various types of generators in lecture 5 or 6. Just go through that. So plus, what is your armature current? 205 into, what is armature resistance? 0.02 plus V brush drop. Here I should write total brush drop voltage. Total brush drop. But what is the question in the given? The given brush drop is 1 volt per brush. Then how many number of brushes will be? See, minimum number of brushes will be, this is one brush, this is another brush. So total brush drop, V brush drop is equal to, 1 volt per brush into number of brushes. Into number of brushes. They given 1 volt voltage per brush. Voltage per brush is, so this you write here, like this you write. Voltage per brush into number of brushes. What is voltage per brush? 1 volt. Like that, how many brushes are there? 1 and 2. This is brush number 1 and brush number 2. So 2 brushes. So multiply by 2. 1 into 2 is how much? 2 volts. See, brush drop voltage will be as less as possible. Okay. So generally we are neglecting, even though if they are given in the question, then you can add that equation in the voltage relation. If they are not given the data, you can neglect it. Why we are neglecting? Because very small voltage. So what is the brush drop? We got total answer 2 volts. Okay. So minimum 2 brushes. In comparison of lap and wave winding, I given in wave winding number of brushes is equal to always 2. In lap winding number of brushes is equal to number of poles. But you can also use minimum number of brushes as 2 even for lap also. Okay. So that is a higher level topic. Don't get detail in that how many brushes we should take depending on the type of winding. Don't get worried. So as a first year student, you just think number of brushes is equal to number of poles in lap winding and number of brushes is equal to 2 for wave winding. But in problems, if they are not specified any winding data and all, you would simply take 2 brushes, 1 and 2, that's it. Okay, number of brushes is 2 multiplied by voltage per brush. In one brush, 1 voltage, 1 volt drop. Multiply by number of brushes, 2 brushes. Why I have taken 2? Minimum possible is 2. We cannot collect the quantity from 1 brush. Minimum we require 2 brushes. Okay. So therefore, now I got everything. Total V brush drop is 2 volt. Now you do this, all this in calculator. Then that is the final answer. If you do this much, you will get 8 marks. See how simple it is. We can do this. Do along with me. We can check it. Who will give first answer? 200 plus 205 into. So 205. No, I am writing 250. 205. Don't do such mistakes like me. Okay, 205 into 2 plus 2. So we got answer 206.1 volts. So 206.1 volt. So this is the voltage generated. Okay, the generated EMF is this much. But what is the voltage available in the load? 200 volts. Where is the remaining voltage? It is in the form of drop, armature drop and shunt field drop. Okay, got it? So please pause the video and then copy down. 8 marks problems. Okay guys, next problem. A shunt-wound DC generator delivers delivers means output side, load side. Delivers 496 ampere. So what is that? Delivers 496. Delivers means output side. Output what we have? Load side. What is the given value? Current. So given load current is 496 ampere. So 496 ampere. A shunt on DC generator delivers 496 ampere at 440 volt supply. At 440 volt, that is a terminal voltage. Okay. To the load. At 440 volts to the load. Load side 440 volts. The resistance of shunt field coil is 110 ohms. 110 ohm is resistance of shunt field coil. And that of armature winding is 0.02 ohms. So armature winding resistance is 0.02 ohms. And they ask a direct question. Calculate EMF generated in the armature. Okay. So first you write the diagram of shunt generator. Indicate all the values whatever given in the question. So finally, EMF generated in the armature of a shunt generator is Eg is equal to Vt plus IaRa. If they given brushstroke data, then you write plus V brushstroke. If they not given, then don't write. Okay. Now what is Vt 440 plus armature current I need to find out. So how to find armature current? Ia is equal to current relation. Ia is equal to IL plus ISH. Addition of this two, it gives armature current. Load current, they are already given in the question itself. 496 ampere. And shunt field current is Vt by RSH. What is Vt? 440 volts. What is shunt field resistance? 110 ohms. By dividing that, we got 4 ampere current. That is shunt field current. Now substitute IL and ISH in the Ia equation. So what is IL? 496. ISH 4. So we got armature current 500 ampere. Now you substitute this armature current value here. What is armature current value? 500 ampere. So Ia into Ra. What is armature resistance? 0.02. Just you simplify this, you will get answer 450 volts. By that, problem ends. See how simple problem it is. See, like they will ask like this. What you should do? You should practice writing voltage and current relations on all types of generators. Rest everything, simply catch the data and put it in the equation. You will get exact solution. If you do this thing correctly, calculator. Otherwise, you may get wrong answers. Understood, guys? So cross verification for all types of generators. You should get Eg value should be more than terminal voltage. Okay, load voltage. Your generated voltage should be higher than load voltage or terminal voltage. You should cross verify this condition whenever you are solving problems on all types of generators. Okay, got it? See, look at here. What is Vt? 440. What is your Eg? 450. This condition satisfied. So, remember this is called concept. Okay. And other thing is your armature current should be more than load current. This is also a concept while solving problems on shunt all types of generators. Ia should be more than IL. But this one is valid only for other generators but not valid for series generator, because series Ia, IL both are same. Okay, for other generators this relation holds good. See, what is Ia? I got 500. What is IL? 496. Ia is more than IL. Okay, and coming to resistance data. In resistance data, if it is shunt field winding, that resistance is very high and armature resistance should be very less. However, irrespective of any type of generator, in the question they should give resistance value by this way. Armature resistance and series field resistance should be as less as possible and shunt field resistance should be very high. Very high means not several thousand ohms, several mega ohms. Ia means 110 ohms. With respect to Ra, this resistance is very high. 110 ohm is very high. 0.02 ohm is very low resistance. So Ra, RSC, they should give lesser value, and shunt field winding resistance they will give higher value. That indicates the given question is correct. Okay, fine. We can solve other problems. Pause the video, copy down the solution. Okay guys, next question. Question number 4. A 4-pole lap-wound shunt generator delivers 200 ampere at a terminal voltage of 250 volt. What type of generator? Shunt generator. Diagram I written here. So it's going to deliver a load current of 200 amperes at 250 volt supply. If the field and armature resistance is 50 and 0.05 ohms, 50 is field resistance and armature resistance is 0.05 ohms respectively. Neglect brush drop data not given. Neglect brush drop. Calculate the following parameters. Armature current per parallel path, EMF generated and power developed. 8 marks question asked recently before lockdown. Sorry, after lockdown, exams conducted little late. So that's why it is September and August. Initially it was conducted June, July. So they conducted in the month of September. Okay, August and September. See, let we can see this. Write the diagram, indicate all the data given in the diagram itself. Let's find first armature current. What is armature current for shunt generator? IL plus ISH. IL is given 200 directly. How to find ISH? This voltage by this resistance Vt. This is Vt. Vt by RSH will give ISH. So Vt by RSH 250 by 50 you will get 5 ampere. So ISH is 5. Substitute here. IL plus ISH 200 plus 5 205 ampere. First question is completed and you can take 2 marks out of total 8 marks. Each question carry 2 marks. So 8 marks. So 2 marks you got it. Next is current per parallel path. Okay. Current per parallel path. See, armature current per path. They didn't ask what, whether load current or shunt field current. They didn't ask specifically. But generally they asked current per parallel path. See, where the windings is done in the armature. Okay. The number of parallel path in the armature windings. So therefore you should take the current as armature current. So armature current per path is equal to armature current divided by path, number of parallel path. See, since it is lap wound machine, in lap winding, number of parallel path denoted by letter A, number of parallel path is equal to number of poles. How many poles? 4 poles. Therefore, I am dividing this entire 205 ampere current divided by number of parallel path. How many path? 4 path. 205 by 4 I got 51.25 ampere. Means there are 4 parallel paths. In one path this much current is flowing. That is the meaning. Okay. Next, EMF generated. What is EMF generated in shunt generator? E is equal to Vt plus IaRa plus V brush drop. But you should not take that. Because why? They given neglect brush drop. So don't take that. So substitute all the values. What is Vt? 250 plus. What is armature current? 205 into what is armature resistance? 0.05. So just simplify everything. You will get Eg 260.25 volts. Then similarly, power developed. Where power will be developed? In the armature. So therefore, generated voltage Eg into Ia. Generated voltage is this much into what is armature current? Armature current is how much we got? 205 ampere. So just multiply that, you will get total power developed, that is 53.35 kilowatt. Understood guys? Pause the video and then copy down the solution in detail. So 8 marks problems. See, till now they asked problems on generators on shunt generator only. Till now for 18 scheme students. Okay. So this time they can ask series generator problems. They may ask series generator problems. So next problem I am going to take series generators. Later some problems on long shunt and short shunt. So that much problems are sufficient to face the university examination. So pause the video and copy down and we can come with new problem. Okay dear students, one more problem on shunt generator, slightly different. See, they given EMF generated in the armature of a shunt generator is 625 volt. For a shunt generator, this is the generated voltage. So far we are finding Eg only. Now they given this value Eg 625 volt. When delivering its full load current of 400 ampere. So load current is here. Full load current. What is the load current? Delivering full load current of 400 ampere to the external circuit. This is external circuit. So generator, what it will do? It will generate some voltage. That voltage we can give to the external load, which requires electrical input. So it delivers 400 ampere to the external load. The field current is 6 ampere. What type of generator? Shunt current. Shunt generator. So corresponding field current will be what? Shunt field current. So the field current is 6 ampere. So and the armature resistance is 0.06 ohms. What is the terminal voltage? These are the data given. They are asking what is the value of Vt. So first find armature current. Totally armature current you find out. What is armature current? IL plus ISH. Okay. What is the load current? 400 ampere. What is the shunt field current? 6. So 400 plus 6, 406 ampere. So this is the armature current. Now write voltage relation. What is voltage relation for shunt generator? Eg is equal to Vt plus IaRa plus V brush drop. But that don't write that one because brush drop is not given in the question. So don't take that, neglect that. So now they are asking Vt. What we can write Vt equation? Vt is equal to Eg minus Ia into Ra. So take this IaRa drop this side, left hand side, it become minus. So you are writing equation for Vt. So from this what we get Vt? What is Eg value? What is generated voltage? 625 volt. So 625 minus what is the armature current? 406 into what is the value of armature resistance? 0.06. 0.06. So do it in calculator. So you will get 600.64 volt. So this is the final answer. So you will get the terminal voltage is 600.64 volts. This is the terminal voltage. Like this also they can ask question. So far question number 1 to 4 they given this data. From that we calculate generator voltage. Now reverse way. They given Eg, they can ask Vt also. Okay. Mark this problem important. Pause the video and then copy down the solution. Okay, dear students, now we can do problems on series generator. Dear students, pause the video and then copy down the question. Okay, what is the question they given? Series generator. See, I am writing diagram for series generator. Okay, you always write diagram, so that gives a very accurate result while solving the problems, and you can't do any mistakes while doing the problems if you written diagram for the given generator. So this is a load, and this is series field winding resistance RSC, armature resistance Ra, and generated voltage Eg, and voltage available at the load point, that is Vt. Okay, voltage available at the load point is Vt. So this question only they asked, what is the terminal voltage, okay, for a given generator. See, a DC series generator has an armature resistance of how much? 0.5. Armature resistance of 0.5 ohms and series field resistance of 0.03 ohms. What is the value of RSC? 0.03 ohms. Full stop. It drives a load of 50 ampere. See, this generator is driving the load of 50 ampere. So what is the load current? So load current is 50 ampere. It drives a load of how much? 50 ampere. So that will be written here. Later they are given some other data. If it has 6 turns per coil, 6 turns per coil, and total how many coils? 540 coils. See, this question is similar to, see, your coils are nothing but number of slots. Assuming single layer winding, the number of coils is equal to number of slots. Okay, so 540 coils. So the given total number of coils is 540 coils. So 540 coils you can consider as 540 slots. In one slot, how many turns are there? 6 turns in one slot. Okay. Otherwise, they are given how much? 6 turns per coil. 6 turns per coil can also be written as 6 turns per slot, because we have taken one coil is equal to one slot, assuming the winding is single layer winding. Okay, that data and all not given, so don't take much in detail. There is a lot of concepts are there in armature winding. So you consider 540 coils is equal to 540 slots. See guys, next 6 turns given. In one slot, how many turns? 6 turns. So for total 540 slots, how many turns? You get that many turns. So that you can find out later. But one turn is equal to 2 conductors. One turn is equal to how many conductors? 2 conductors. Means this is one conductor, this is another conductor. Conductor number 1, conductor number 2. If I join these two conductors, then we can call it as one turn. Then we can call that as one turn. Understood guys? So to make one turn, how many conductors you required? You required 2 conductors. Similarly, for 6 turns, how many conductors required? 12 conductors. Okay. 1 turn, 2 conductor. 6 turns, how many conductors? 12 conductors. So therefore, this we can modify as 6 turns per slot can also be written as 12 conductors per slot. So we can write 12 conductors per slot. Now find total number of conductors. What is the total number of conductor? Number of slots into conductors per slot. How many slots are there? How many slots? 540 slots. 540 slots. In one slot, how many conductors? 12 conductors. Okay. In one slot, how many conductors? 12 conductors. Multiply this, you will get that many number of conductors in the armature winding. So we can do that. 540 into 12. So we got 6480 conductors. These many conductors we got. And it is driven at a speed of, see, this generator is running at a speed of 1500 rpm. 1500 rpm. And they are asking, calculate the terminal voltage at the load, and they are given some other data. Assume 4 poles. How many number of poles? 4 poles. What type of winding? Lap winding. And what is the flux is given? Flux per pole is 2 milliweber. Flux per pole is 2 milliweber. See, they are given your generated data. Okay. So what is Eg? Eg can be calculated by directly in this way. Pi p nz by 60A. So now, see, this is a difficulty level question. They combined EMF equation problem and types of generator problem. Okay. So this type of question can also ask in examination. So what is the flux is given? 2 milliweber. 2 into 10 raised minus 3. What is the number of poles? 4 poles. And speed is 1500. What is the speed of the machine? 1500. And what are the number of conductors? Total number of conductors is 6480 divided by 60 into what is A? Number of parallel path. What type of winding given? Lap winding. If it is lap winding, A is equal to what? Number of poles. Number of poles is how much? 4 poles. So calculate. So from this you will get generated voltage. So that we can do how much we get. 2 into 10 raised minus 3 into 4 pole into 1500 rpm into 6480 conductors divided by 60 into 4. So we got, this is the voltage generated, 324 volts. Because in order to find this Vt, obviously I should know Eg. But Eg is not given directly, they are given indirectly. So from this equation we find out Eg. Next job is we have to find terminal voltage. For that, you should write voltage relation of DC series generator. So what is the voltage relation of DC series generator? Eg is equal to Vt plus Ia within the bracket Ra plus Rse plus what they given in the problem. Why I written plus extra means, that is they given brush drop data in the question. Whenever they given brush drop, you add that data in the question in the voltage relation. Whenever they given brush drop, so V brush drop. See, this V brush drop indicates total brush drop in the machine, total brush voltage drop in the machine. So now you observe the question, whether they given voltage per brush or total brush drop. Sorry, they given total brush drop. Total brush drop is 2 volts. See, Eg you know 325, Vt you have to calculate. What is armature current in series generator? Load current is 50. Series field current also 50. And armature current also 50. Because in series generator, Ia is equal to Isc, Isc is equal to IL. All currents are equal. Therefore, we have to take here armature current 50 ampere. Okay. What is Eg? 324 is equal to Vt plus armature current 50. What is the armature resistance? 0.05 ohms. Plus, what is series field resistance? 0.03 ohms. Okay, 0.03 ohms. Plus, what is total V brush drop? Total V brush drop is how much? 2 volts. So, total brush drop is 2 volt. So, you write simply 2. See, only one unknown parameter. You can easily find this. Okay, Vt is equal to 324 minus of this minus 2 volt. Like that you can write. Now I am solving directly. We can check how much we get. 324 is equal to Vt plus 50 into 0.5 plus 0.03 plus 2. Okay, by solving that, we got terminal voltage 295.5 volts. We got a terminal voltage 295.5 volts. Understood now, guys? What is the question they asked? So the terminal voltage is 295. What I said earlier concept, remember the concept for all types of generators. Your Eg should be more than Vt. What is Eg? 324. What is Vt? 295.5. So Eg is more than Vt. But Ia should be more than IL. That is valid for other generators, but not for series generator. Because for series generator, IL, Isc, Ia all are equal. Okay, guys, I hope you understood. We got answer 295.5 volts. Okay, guys, pause the video and then copy down this detailed solution. Okay, mark this question as very, very important. In order to fail the students, university can ask this type of questions. Okay, got it? So don't worry, we can predict all types of questions, and we should be ready to face all types of questions, whatever asked in examination. So if they given easy questions, you can easily crack the exam. Okay, if it is difficulty also, you can face the questions. Okay, ultimately you will be the topper. Okay, so fine. So pause the video, copy down the solution. We can see some other problems. So guys, next is question number 7. A problem on long shunt DC compound generator. A long shunt DC compound generator drives 20 lamps. All are connected in parallel. See, why it is driving lamps means, we know the application of generator. We can use generator for lighting purpose, and we can use the generators for charging the batteries. Okay, understood? So we can draw first the long shunt DC compound generator. So let's start with the solution. Long shunt DC compound generator. See, compound generator means it includes both the shunt field winding and series field winding. Okay, so this is a series field winding. always connected in series with the armature, and shunt field winding is connected across series combination of these two. These two are always connected in series. Across this combination, if I connect the field winding, shunt field winding, then it is called long shunt compound generator. Okay. So now it is a load. Now the load, at the load side, there are 20 lamps. Okay. So what they given? 20 lamps. So this is lamp 1. Like this, there are 20 lamps. All these lamps are connected in parallel. All the lamps are connected in parallel. So all the lamps are connected in parallel. Terminal voltage is 550 volts. What is the terminal voltage? 550 volts. What is this? Vt. The voltage across the load is 550 volts. With each lamp resistance and the given resistance of each lamp. So the resistance of each lamp is how much? 500 ohm resistance. One lamp resistance is 500. Like that, there are 20 lamps. Means each and every lamp is having same resistance. Means 500 ohms, 500 ohms, 500. Like that, 20 are connected in parallel. If the shunt field resistance is 25 ohms, what is the value of shunt field resistance? 25 ohms. So 25. And series field resistance, see RSC is how much? 0.04. Series field resistance of 0.04 ohms. And the armature resistance of 0.06 ohms. And they are asking, calculate the armature current. So this is armature current. What is the value of this current? That we need to find out. See, these two are connected in series. Whatever the current Ia is there here, same current flows through series field winding. So therefore we can make series field current and armature current both are equal till this point. After that, this entire thing is load, is having some resistance. That load and this resistance both are connected in parallel. So this current will divide in these two branches. So part of the current flow through load side, that is load current IL, and part of the current flow through shunt field winding, that is ISH. This is about a diagram how to write for the given question. Like look at here, calculate the armature current and generated EMF. You have to calculate Ia value and then what is the voltage generated. Okay. So now what is Ia? For shunt generator, for long shunt generator, Ia, apply KCL at this node. Your armature current will be sum of load current and shunt field current. So IL plus ISH, that gives an armature current, and that armature current is also same as series field current because these two windings are connected in series. Okay. So how to find IL? So now I need to find load current. So how to find load current? See, load is given resistance. They given resistance. Resistance of one lamp is 500. Like that, how many lamps are there? 20 lamps. All are connected in parallel. That effective will get what? One load resistance. Voltage by load resistance, what you will get? Load current. So load current is written as Vt by load resistance. Vt by load resistance. Load resistance not given, we have to find the load resistance. So therefore, load resistance is equal to, what is the resistance formula? All the resistance, all this lamp, individual lamp resistance is 500 ohm resistance. Like that, how many lamps are there? 20 lamps. Means the load resistance will be in this form. Okay, this is one resistor. Okay, one resistor. Like this, 20 resistors all are connected in parallel. What is the effective of this resistance? That is the load resistance. So since we have identical values of resistances are connected in parallel, we have a formula RL is equal to, R effective is equal to R by N. When identical lamp resistors are connected in parallel, the effective resistance is nothing but load resistance in this problem. Generally, the effective resistance is R by N. So what is the value of resistance of one lamp? 500. Like that, how many lamps are connected in parallel? 20. Like that, 20 lamps are connected in parallel. So from this you will get a load resistance of how much? Load resistance of 25 ohms. Now take this resistance here. So Vt is how much? Vt is how much? 550 volt divided by 25 ohm resistance. So by solving this in calculator, do it in calculator, you will get a 22 amperes. So that is what? Load current. So this is approach 1. Approach 1, some students will do like this to find the load current. What other students will do? This voltage by this one resistance. Okay. Vt by R, resistance of 1 lamp. They are going to find current in 1 lamp. Current in 1 lamp. Like that, they keep on calculating current in all the lamps. In parallel, supply current is equal to sum of all the currents. Adding all these currents, you will get the load current. That is also correct. That method also I am doing now here. So total load current is equal to current in 1 lamp. Current in 1 lamp into multiplied by number of lamps. Into multiplied by number of lamps. How to find current in 1 lamp? Voltage across 1 lamp divided by resistance of the lamp. Okay. What is current in 1 lamp? Vt divided by resistance of a lamp. Into how many number of lamps we have? 20. So into 20 lamps. So what is Vt? 550. What is the resistance of 1 lamp? 500. Multiply by 20. 550 by 500, you will get 1.1. Multiply by 20, you will get 22 ampere. See, that is the load current. So both the methods you got same answer. So it varies from student to student how he is going to analyze, he or she, how the problem is analyzing. Based on that, the solution will be slightly different. Ultimately, you will get same answer of load current. Okay guys, copy down both the methods. Next, load current calculated. Next, calculate shunt field current. So how to calculate shunt field current? Vt by RSH. Vt by RSH. What is Vt? 550. What is shunt field resistance? 25. Both this load resistance and this both are connected in parallel. So obviously voltage will be same. So voltage by resistance. 550 by 25 is the shunt field resistance. Again we got 22 ampere. So finally, what is the armature current? Armature current, they asked to calculate the armature current. What is armature current? Load current plus shunt field current. What is load current? 22 ampere. What is shunt field current? That also 22 ampere. So finally, your armature current is how much? 44 ampere. Next, what is the next question? Calculate the generated EMF. So Eg, you must remember voltage relation of long shunt compound generator. So Eg is equal to Vt plus Ia into Ra plus Rse, okay, plus V breast drop. Breast drop data not at all given the question, so neglect that equation. V plus V breast drop, you neglect it because data not given. So let write all the values. What is Vt? What is terminal voltage? 550 plus what is your armature current? 44 ampere. Within the bracket, what is armature resistance? 0.06 plus what is your series field resistance? Re plus Rc. Series field resistance is how much? 0.04. Guys, do this in calculator. Do it in calculator. What is the concept? Your Eg should be more than Vt. Then only it is generator. So by solving in calculator, you will get 554.5 volts. Okay. Check out the answer. Wait, I will also do along with you people. So 550 plus 44 into 0.06 plus 0.04, we are getting 554.4 volts. Okay, make corrections. So the correct answer is 554.4 volts. Understood guys? So pause the video and then copy down the solution. So this is application based question, knowledge based question. So to filter the students in examination, universities, some expert professors, we are going to set this type of questions. Okay, not filtering the students is not that intention, to check the understanding level of the students, whether the students know this questions and all. So they are going to check. Okay, in order to differentiate the well learned person and partially learned person. Okay, so guys, pause the video and then copy down. Okay, dear students, next one is a short shunt compound generator problem. A short shunt DC compound generator supplies a current of 75 ampere at a voltage of 225 volt. See, supplies a current of 75 ampere at a voltage means at the terminal voltage. At a voltage of 225 volts, it is going to supply a load current. Supplies a current of 75 ampere at this voltage, means obviously that will be at the load side. So what is the voltage? Sorry, what is the current? 75 ampere. See now, in short shunt compound generator, if I connect shunt field winding only across armature, it becomes short shunt. If I connect this winding across these two combination, if I connect this winding here, then it becomes long shunt compound generator. See now, series field winding and load resistance, this and this both are connected in series. Therefore, ISC will also be 75 ampere. And they given calculate the generated voltage. They are asking calculate EG. If the resistance of armature, see the given order in this order: armature, shunt field, and series field winding order. What is the first one? Armature. So armature resistance is 0.04 ohms and shunt field is 90 and series field resistance is 0.02 ohm resistance respectively. See now, see this armature going to deliver current IA, develop some current IA, that current going to supply to the load side, external circuit. So after this particular node, this armature current will divide into some current flows through shunt field winding, that is ISH, and some current flow through series field winding, that is ISC. Same current will be flowing to the load point, that is IL. ISC, IL both are equal. So my question is how to find EG. So you have to remember voltage relation of short shunt compound generator. That is EG is equal to Vt plus IaRa plus ISC RSE. Don't take Ia common factor. See, this current is different, series field current is different in short shunt compound generator. See now, you have to find the value of Ia. How to find Ia? So later we can substitute here. We can find armature current. What is Ia? Apply KCL at this node. Load current plus shunt field current is equal to what? Armature current. So IL plus ISH. What is IL given in the question? 75 ampere. Then how to find ISH? Now I need to find ISH. To find ISH, you have to find voltage at this point. This voltage divided by resistance, you will get shunt field current. So therefore, ISH I will write here. ISH is equal to Vt plus IaRa+V divided by RSH. That gives shunt field current. So what is the shunt field current? What is Vt? 225. 225 plus what is the load current? 75 into what is the series field resistance? 0.02. 0.02 series field resistance divided by shunt field resistance is 90 ampere. So using calculator, find this solution. What is the answer you will get? So 225 plus 75 into 0.02 divided by 90. So from this we get a shunt field current of 2.51 amperes. 2.51 ampere. So now Add it here. What is IA? IL plus ISH. IL is 75 ampere and ISH is 2.51. So adding this, you will get 77.51. So plus 75. So we get 77.51 ampere. That is the value of armature current. And what about series field current? 75 only. So now substitute here. What is Vt? 225 plus what is armature current? 77.51 into what is the armature resistance? 0.04 plus 0.04 plus, and what is ISC? See, in short shunt compound generator, ISC is equal to IL only. So that is 75 into series field resistance 0.02. Now you simplify all this in calculator, then you will get correct answer. 225 plus 77.51 into 0.04 plus, do along with me, 75 into 0.02. So by doing this, we got answer 229.6. 229.6 volt. 229.6 volt. So this is the generated voltage for the given question. Okay. Understood, guys? So pause the video and then copy down the solution. See, voltage at this point will also be calculated in this way. Generated voltage minus IaRa drop. This voltage minus drop, what is left remaining voltage? That is voltage at this point. That voltage by resistance, that is ISH. But starting, EG we don't know. That's why we come in reverse way. This voltage plus this voltage drop, adding this and this, will get voltage at this point. Okay. And again, for that voltage, add this voltage IaRa drop. So adding this, this and this together, we get EG. Look at here. Vt plus IaRa plus ISC RSC. Vt is this one, ISC RSC is this one, IaRa is this one. By adding all this, what you will get? EG. Okay. But ultimately, I need to find voltage at this point. Voltage at this point should be, you take IaRa drop this side. Then Vt plus ISC RSC is voltage at this point. But ISC and IL both are same. That's why I written here Vt plus IL RSC. Otherwise, you can write Vt plus ISC RSC. That is also correct. Okay, guys. So pause the video and then copy down. Copy down the detailed solution. Okay, dear students. So far I solved 8 problems. Okay, and I given 2 problems for your side to improve the confidence. So I given one problem on short shunt and one problem on long shunt. Please pause the video and then copy down these 2 problem questions and leave some space. Try to solve these questions, and I given answers for both the questions. So for first question, it is short shunt compound generator. It supplies a load current of 100 ampere. See, IL value is 100 and Vt is 250 volts. The generator has following winding resistance. RSH is given, Ra is given, and series field resistance is also given. Find the EMF generated if the brush drop is 1 volt per brush. So see, in this question, brush drop is given. In voltage relation of short shunt generator, you write V brush drop. So there you should take 1 volt per brush. What is the minimum brushes? 2 brushes. So into 2. 1 volt into 2, you will get total brush drop is 2 volts for this problem. Then all data is given. Find armature current and then substitute in the formula, you will get EG 272.2 volts. So if you got this answer, 100% you will pass electrical. 100%, there is no doubt. Next, a DC. If you don't know how to do this, refer previous problem, question number 8, because I done problem on short shunt compound generator. Refer that and try to solve this question. Next, a DC long shunt compound generator. For this, you refer long shunt compound generator problem. So delivers a load current. See, IL is given 50, Vt is 500, Ra this much, RSC 0.03 and RSS 250 respectively. See here, lamps and all not given. Whenever lamps are not given, you simply write in the output side load. That's it. Okay. calculate the generated EMF, the armature current, and allow 1 volt per brush for contact drop. Okay, here also again minimum brushes is 2, 1 brush voltage is given 1 volt, so 2 brushes 2 volts. So write the voltage equation of voltage relation of long shunt compound generator, then find Eg. Okay, Eg should be more than Vt. Answer is given 506.16. If you solve these two problems, okay, you can get full marks in module 4. There is no doubt. Okay, on generators. Understood, guys? So, guys, totally these 10 problems are more than sufficient. But till now in the university examination, they asked problems on DC shunt generator. So you concentrate more on shunt generator problems, and along with that you study other problems also. One problem on series I done, one problem on long shunt and short shunt. Later I given 2 problems, okay, for homework. Okay, you just give a try for these 2 problems, and the solution is also available in the notes. You just go through that. If you didn't get solution, you can ask me in WhatsApp. I will interact with respective student, okay, for giving solution for these 2 questions. So guys, please subscribe our channel and give like to our videos. So please keep supporting us. So due to time constraints, so I am unable to upload the video lectures of the subject, so in a daily basis. So I will try my best, and also I have some technical issues and financial issues. So once it is sorted out, I will upload the videos at the earliest. So by April 19th the exam will start. So within that I try to finish it off all the remaining portions. I will try my best. So don't depend on my lectures. However, if the lectures are, please click the bell icon. You will get the latest video lectures. So you can watch it if it is convenient for you. If you are free, you can watch it. Okay. So for the next semester onwards, for those who are shifting chemistry cycle to P cycle, for them it is really useful. So have a nice day. Take care. Bye bye. So don't forget to subscribe our channel. Take care. Bye bye. Meet you on next video. So we are going to start DC motors.